Hi there, it's time to show another film, and this is an educational film. One of my favorite subjects is math, and so this is called The Language of Algebra. Now, even though it's on a Kodak reel, it's not made, the film is not made by Kodak, it just happens to be the reel that it's on. So it's a math film, and hope you enjoy it.
What is a symbol? Some symbols are signs telling us what to do, or what not to do. Or telling us what we are going to do. Some symbols identify things, or people, or places. Often, symbols develop naturally over a long period of time. Once there was a piece of land with 3 pine trees on it, which the Indians called 3 pines. When the first Frenchmen came here, they saw the 3 pine trees, and they saw a bird sitting in each of the trees. So they called this place La Place des Trois Oiseaux. As time went on, this land came to be called Plat-Trois. Then Plat-Trois. And finally, just the platter. And everyone supposed it was so called because it was flat, like a platter. But at least when they said platter, they knew what land they meant. It was a word symbol for this piece of land. A long time later, Mr. Jones bought the land. He chopped down the trees and graded the ground for a subdivision. He surveyed and marked off a portion of the land that was 300 feet long and 200 feet wide. And this he called his real estate, which he wrote as R. This is a letter symbol for his land. He wanted a street around this section. The contractor said, "Your street will be as long as the length, plus the width, plus the length, plus the width." He substituted abbreviations, or symbols, for words. This is a mathematical formula. Now, although the street was paved in this order, the formula can be rearranged and simplified by combining like terms. Or this can be simplified in another way by combining these like terms. Parentheses are used here to show that both the L and the W are to be multiplied by 2. Now he substitutes the information known. L, or length, 300 feet. W, or width, 200 feet. By replacing symbols with quantities, he evaluates the formula. He simplifies what is between the parentheses. The street is 1,000 feet long. Mr. Jones liked facts, and he wanted to know the area of his real estate in square feet. He knew that the area would equal the length multiplied by the width. The multiplication can be indicated with a dot, or simply like this. A equals LW. He evaluates the formula by substituting 300 feet for L and 200 feet for W. And by multiplying, finds that the area equals 60,000 square feet. Mr. Jones marked off his real estate to divide it into 4 equal plots. He said the area of each plot equals 1/4 the area of my real estate. This is the area of the plot. And this is the area of the real estate. Any letter or symbol written below another, such as this P or this R, is called a subscript. These are read A sub P and A sub R. Mr. Jones uses them to show clearly which area he means. Again, evaluating, and simplifying, the area of the plot is 15,000 square feet. To check this, he used another formula. The area of each plot is length times width. Now, evaluating, the area of the plot again equals 15,000 square feet. Then the plots were sold, and 4 houses were built by Mr. A, Mr. B, Mr. C, and Mr. D. Each of these houses looks different, yet each can be labeled house, or simply H. And to clearly tell which is which, subscripts are used. Mr. Jones was curious to know how many people lived on the property. He wanted to line up everyone and count them, but they were never all home at the same time. So he said, if I know the number of people that live in each house, I can use this formula. He telephoned and learned these numbers, and so found out that 19 people lived here. The milkman also was interested in how many people lived here. He was concerned about how much extra milk he'd have to carry, but he used a different formula. He estimated that he would probably need 1 quart for the 2 parents in each house, and 1 additional quart for each child. He said, the milk I must bring will equal the number of houses plus the number of children. The parents decided they would each set aside part of their plot for a community play yard. The play yard was to be 40 feet square. So the amount of fencing needed was 4 times the length of one side, minus the gate. In the play yard, one of the fathers planted a tree, and when the tree was high enough, they decided to put 3 swings on the branches. To find out how much rope they needed for this number of swings, they said they would need twice the distance of the limbs from the ground, minus twice the distance of the swings from the ground. K is the extra rope needed by tying and so forth. Then 2 is taken out of the parentheses. And 63 feet of rope is needed for the 3 swings. We can see that a great many facts can be told about this property by simple mathematical sentences or formulas. Some of these statements, like the basic formula for area, will have only one set of conditions for their solution. The area will always remain the same. But others, like the formula for finding the number of people who live here, may change with new conditions. Babies are born, people move away. These formulas could be used for working with very large areas and populations. But for use in modern computing machines, the symbols are abstracted even farther. Mathematical information can be written in a language of punched holes. The position of each hole on a card stands for a certain fact. When these punched cards are fed into a computing machine, the answers to problems which would require months to solve with pencil and paper can be found in moments. Symbols allow you to set down in the simplest manner the facts you know and what you should do with them.
Hope you enjoyed it.